Hello, I'm Derek. I'm a software engineer at Syntasso, and today I'm going to give you an introduction of Kratix. We're going to cover the main concepts, and it should serve as a basis for you to do the workshop that is available in docs.kratix.io, and also as a refresher in case you want to go back and remember, remind yourself of the core Kratix concepts. So the core of Kratix, in a nutshell, this diagram represents everything that Kratix offers for you. The core concept of Kratix, the main component of Kratix, is this thing called a promise. And a promise is the definition of something as a service. It's what you use to provide to your organization in your platform something on demand to your users. So in this diagram, you can see there are many different components. So let's go through them, each one part by part. The first thing you can see here in the middle is the promise API. So the promise API is what you define in the promise, all the settings and all the properties that the user can configure. It's basically the API, right? Is what the user can actually configure and set when requesting that particular service. So let's say that we are providing Postgres as a service. This may include the VM size or the disk size or the number of backups, the number of replicas, the number of nodes, or it could be something specific to your organization like Postgres versions or even t-shirt sizing. So the API is for you, the platform engineer, to define, and that can be as complex or as simple as you wish. It gives you the opportunity and the chance to decide which fields and how can the user actually configure the semantic value, the semantic meaning of each one of those fields as well. So that's the API. Once you provide the API, you also need to define within a promise what we call the workflow stages. So a workflow is, as you may imagine, is a series of steps that we execute, is a series of containers that we execute to make the requested service reality. So what does it mean to provide Postgres as a service in your organization? It could mean just go and generate me a YAML document that contains the deployment or the Postgres operator request, right? Or it could be anything like running Terraform. It could be actually generating Postgres in the cloud. You can do anything you want in here. So the workflow stages are containers. Kratix will execute them one by one. And here you also have the opportunity to include any custom policies that you want, any automation, any business processes. Maybe you need to notify someone if someone requests a production database, or maybe you need to send an email or need some manual approval processes. So the workflow stages, in the stages you can define anything. If you can write a code for it, you can define that in the workflow stages. So that's what makes the promise specific to your organization. So once the user sends the request in, and how can the user send the request in? That's the top layer over there. So Kratix has nice integrations with Backstage and Port, but you can use any other GUI that you want, or even use the API directly via kubectl or via your own interfaces, or you can also use GitOps. So we are not opinionated in how you interact with the platform. The important thing is the user will interact with one of those systems to send the request to the platform respecting that API. And what does a promise produces? A promise usually produces a set of declarative documents that says this is what I want to be deployed in the back of this request. So a very simple case, if you're thinking about what it is an application running in Kubernetes, an application can be a deployment, an ingress, a service, maybe you have a namespace, maybe you have a config map, you have a bunch of YAML documents that are attached and associated with that application. So in an application promise, you could request what is the image, what is the repository that you want me to build the image from, or something like that. And then the workflow will produce all of those documents. Once those documents are produced, we go to the next stage, which is the GitOps scheduler. So you can see here in the bottom, we have a scheduler. And what that will do is find a destination, a place where that workload can run. So Kratix is also not opinionated about where that runs. It could be in any all public clouds. It could be infrastructure as a code tools like Terraform, Crossplane, Pulumi. It can be another different Kubernetes cluster, or it can be even other automation tools. It can be like Ansible. We can push code to GitHub and have GitHub Actions to run on top of it. So basically, Kratix allows you to define a service, define what it means for that service to be deployed, and schedule that to any destination, to any place via GitOps. And on the left-hand side of this diagram, you have the platform team contributing promises to the platform. So each one of those promises will be built and provided by the platform team, but they can also be built and provided by the specialist teams in your organization. So this is what allows Kratix to be run in multiplayer mode. It allows you to provide different teams in your organizations to define the promises they are specialized with. So, for example, again, on the database scenario, you may have a database team that knows more about Postgres and more about MySQL and how to run those things, and then you can provide a promise and write a promise and provide that to the users of your platform via promise in the platform. So, in a nutshell, that's how Kratix works. So, Lars, we're going to go a little bit more into the details about first destinations. So just to highlight a little bit more about what we mean for destination. So usually a standard deployment of Kratix, you have the platform cluster. In the platform cluster, you have all of your promises installed. And Kratix within the promise allows you to determine where those particular workloads should run. So when I request a deployment, I may want to send that to Kubernetes cluster, standard cluster if it's dev. I may want to send it to a PCI compliant cluster if it's prod, right? Or if it's going to run applications that will handle like sensitive data. But for a bucket promise, I may say, well, I want my bucket promise to actually run in Terraform. I'm going to generate some documents and send it to Terraform Enterprise and have Terraform Enterprise to actually do the reconciliation and the creation of those buckets. So Kratix allowing this multi-destination mode, as long as you have your platform cluster, you can actually run workloads everywhere. So what is a promise? If you look into a little bit more details, it's Kubernetes in the end of the day. So it is a YAML document, and what you have in there is basically 4 main parts. The part number 1 is the API. The API is, as we discussed, is so that those properties that the user can configure, and this is a straight-on Kubernetes CRD at the point of writing. So you can get a CRD and write it in there. You can do any validations that you want. You can determine what are the fields that you want to be possible for the user to configure. You want to know the type, all those things. You build that API, you put that in. If you're familiar with CRDs, you already know how to write an API. The second component, the second part of a promise is the dependencies. We're going to go through into what the dependencies are a little bit more in the next few slides. But the dependencies are what needs to be pre-installed or pre-exist or pre-created before the user can actually send a request for this particular service. So if we imagine a application promise, you may need Nginx to be pre-installed, the Nginx controller, or the load balancer controller to be installed before someone can actually request an instance of that application. Like I want a new application to run, to serve that I need the load balancer controller, for example, to be installed. So this would go into the dependencies. Then we have the workflows, and that's where the magic happens. This is what will transform the set of inputs into the set of outputs and create and generate the services or the software, the deployments that the user requested. So again, for the application promise here, what the workflow could do could be generate a deployment YAML. It could generate a load balancer, not load balancer, an ingress YAML. You could create a bucket running Terraform within the pipeline. You could use APIs. It's just code. Whatever you can write in the code in here, you can make it. Kratix can make it happen. A promise has different hooks for different types, for different like lifecycle events that happen in the promise. You can find more information about that in the docs. And finally, we have the destination rules. As we chatted previously, that Kratix can run workloads in different types of destinations, and here you can say where that should go by using labels and selectors. Again, more details about that you can see in the docs. And you can also see that in action when you go through the workshop. So what happens when the user installs a promise? We're going to go through this process now. So the platform engineer comes to the platform and say, let's install this app promise, right? In this particular diagram, they are installing 2 different promises, an app promise and an AKS promise. The first thing that Kratix would do is actually make the API that is defined within the promise available in the platform cluster. So you can see the arrows that come in here, that API, that CRD, will be available as a new CRD, a new CRD in your platform cluster. The same happens with the AKS cluster. When you install that promise, the AKS promise API that is defined within the promise will also become available. And at this point, if the user comes and say, kubectl get promises, list me what I can request, they should see those two promises that you just installed. So now that CRD is available, what is the next? What next? What does Kratix does next? So what Kratix will do next is actually get the dependencies and install that in the worker cluster that can run those workloads. So for the app promise, for example, we may have as we discussed previously, we may have the Nginx controller, we may have the load balancer controller. So Kratix will get those dependencies and install that in the worker clusters that can run those workloads. And that's now available and ready to serve. But again, the dependencies and the destination selectors that we have in our promise will actually allow you to select where and where those dependencies should be installed. So in this particular deployment topology over here, what we have is the app promise that should be installed. The dependencies should be installed and made available in all of the Kubernetes clusters that I have. So here I have 2 different Kubernetes clusters. Those will be matching to different destinations within my platform cluster. I install those promises, those dependencies will be associated with those destinations, and that is going to be pushed to a Git repo. Because Kratix talks to those other clusters not directly, it's always via GitOps. So Kratix will push to either Git repo or S3 compatible bucket, and then what you usually have is a GitOps agent like Flux or Argo synchronizing and reconciling on the documents that are written to those state store. And you can select those destinations via labels and selectors, via labels basically. For the AKS promise, on the other hand, the dependencies may be some Terraform modules that we have. So what that will probably not run on the same Kubernetes cluster, right? Because this is using Terraform. So what you will likely to do is have a destination that associates with your Terraform system, and then those dependencies will be pushed only to the state store associated with that Terraform destination. So for example, in here, we are running on the Terraform Enterprise. Terraform Enterprise you can configure to synchronize with a Git repo, and as soon as those Terraform files hit the state store, they will be synchronized and created there in your cloud. Again, this is just for diagram purposes. This could be a single Git repo, or it could be many different Git repos and many different state stores, S3 buckets as well, for each one of your destinations. So now that everything is installed and the dependencies are installed, Kratix is ready to serve requests for the users. So what happens when the user sends a request? And that's what you see in the next stage. So the developer, the platform user, will come through any sort of system and like a system interface to interact with the platform. That could be a terminal, it could be Backstage, it could be port, it could be any other interface that you want. But what's going to happen is that new request. So for example, here, if you're requesting a new AKS resource, that request is submitted to the platform cluster and hits the platform cluster. That request is namespaced, so that's how you can control which users can have access to which sort of promises. You can use the normal Kubernetes RBAC to manage all of that authentication and authorization of your resources as well. So that request hits the platform cluster that will be abiding by the promise API, so by the AKS promise API, that CRD that you defined within the promise. And what Kratix will do is kick off the workflows. So the resource create workflow, the first configure workflow, sorry. What those workflows will do is, again, anything that is required to your organization to deploy a new AKS cluster. Here, for the sake of, for example, what we're going to generate is a few Terraform files. So we generate a cluster.tf, we generate values.tf, and some other Terraform files. So we generate a bunch of Terraform files, and in here we have 2 options. We could, within the workflow itself, run the Terraform apply, the plan and the apply, or we can use Kratix, a declarative approach, and schedule that via the GitOps scheduler to a destination. So you can see that I have 3 different destinations in here. This could go to workspace A, B, or C. What happens in the end is that, let's say that it goes to destination A, this will going to be written to the state store associated with that particular destination. So in this case, this Terraform files will be written to this state store. You have, as we had before, right, a Terraform Enterprise agent synchronizing with that particular GitHub repo, Git repo, and then creating those resources. And what it's going to do in the end is actually create in the Azure cloud the actual AKS cluster. So that's how the system comes end to end to fruition. So if you circle back, that's the components, that's the parts of the promise that we went through. We went through the API, went through the dependency, went through the workflows, and went through the destination rules. And the last bit that I want to touch on is compound promises. So one of the powerful concepts of Kratix is this concept of compound promises, which means how can I create fuller experiences by combining different promises together. So for example, our app promise could be as simple as it just generates some deployments. However, it could also orchestrate different promises. So you can have an app that may have a database, that may have a cache using Redis, and that those sub-services can be provided by another promise. So you ended up having a promise that orchestrates other promises, that make uses of other promises. And an example here, if you have a Ruby app promise that can be requested with a Redis, a runtime technology like Knative, for example, and Postgre and databases, you could have in the workflows that generating Redis like a request for each one of those sub-promises. And then again, Kratix will talk to itself via GitOps, so you can send it to the Git state store, and that's going to hit our platform cluster via this GitOps agent, and then those will be like fired up. And then the process that happens down the line here is the same as we covered previously. But what that allows you to do is build that multiplayer mode that we talked again before, right? You have different teams responsible for different promises in your system. They build those promises, and then the platform team can just orchestrate and create fuller developer experiences by using those promises instead of asking the user, okay, so you want to deploy an app with a database, send a request to the database, then a request to the app, and then wire them two together. You can provide that in a promise, and then you can build a higher and higher level of abstractions up all the way up to like fuller development environments, right? The power of compound promises is what makes Kratix really shine in larger organizations. So yeah, that's is all I had for the introduction. If you are going through the workshop, it is a good place to start. Part 1 will cover what you need to do to install and manage Kratix, and part 2 will go through writing a promise. So if you have any questions, drop us in a comment. Otherwise, I hope you enjoy it.